All right. So when is a normal model appropriate?
A lot of question marks.
Or to be exact.
Appropriate.
When a histogram is what?
Symmetric and unimodal.
Yep. Bingo. Unimodal. Symmetric. And this one we haven't really seen yet, but when the normal probability plot is a straight line, primarily be worried about the top two at the moment. If the histogram is unimodal but not symmetric, the normal probability plot is not linear, and thus we can't use the normal model. Once you're done with that, put all of these numbers into a list. Go ahead and make a histogram once you do that.
What's the point? How do you do that again?
Second y equals and stat plot.
Oh, we gotta turn the plots on.
Oh, yeah. I'm really glad you said that. I couldn't figure out why my stat plot wasn't working and it wasn't on.
Right.
What the? There we go. Okay, now we're good.
I'm gonna go to Zoom and Zoom stat.
Zoom stat.
That's not a histogram. I forgot to change it from the. I almost said cat and whisper box.
Cat and whisker box.
What is going on? Hold on.
If
I
it's,
still have that y equals in from calculus. That's
yeah, that's what I had, and then I realized my stat plot wasn't on.
It's on. Okay. What is going on? I don't. Oh. May I have some assistance, please?
Ooh, can I help you?
Sure.
Okay. Okay, so what's the problem?
I'm trying to grab the histogram.
Okay, so yeah, that one's on. That one. So all the other plots are off. So that's the correct list.
Yes.
Okay, so then you go Zoom 9.
Oh, zoom out. I was just saying graph.
Oh.
Let me zoom out.
Yeah, mine looks something like that, Nathan.
Something like that.
Exactly.
Alright, now I'm going to show you if you needed to put labels on here, how you would label it, okay? So if you hit, figure out how to get it up here. Nope, too much. Nope, not enough. Okay. So right now we just have this. We don't really have labels. And without going back through the list of numbers, you would be counting and guessing what things are. But if we hit trace, it'll go in this box. It'll tell you what the min value was and the max value, so what the lower and the upper is for this box. So this one is telling us that we have 9.4 here on the left, and that this one is 11.6 here on the right. And this n equals 1 tells us that there's one number in this box. Okay, one number is in that range. Then if you arrow one to the right, the next one, it says the min is 11.6, the max is 13.9 basically. And there are 13 of those. Arrow to the right, 13.9 and 16.1. And there are 9 numbers in this box. To the right, 16.1 and 18.3. There are 15 numbers in this box. And then next one, 18.3 to 20.6. And there are 5 in this box. And then arrow over. There's nothing here. There's a gap here. Then 22.8. Arrow over again. Up to 25.0. And there's 1 in this box as well. So using trace, we were able to see what actually is in each box and the dimensions on it, and we could have, done that back when we were doing it before as well. So if you do it on your calculator, that will tell you what each little gap, or not gap, each bin is. Questions on that part? All right, so then part B uses this. Or, well, I guess this whole next page does. Calculate the one variable statistics. And you could test for outliers here too. We don't really need to necessarily, but we can. Alright, so an X bar of 15.6, a standard deviation of 2.5 or 2.6, min of 9.4, Q1 13.6, median 15.8, Q3 17.5, and max 22.8.
What are we going to do?
Stat, calc, one variable stats. Does that work?
Yeah. So the standard deviation that we should use is the S.
Yes.
X.
All right, so this next part, we want to go ahead and basically draw what this model should look like. So we're going to put or draw like our curve, put our mean, and then go out 3 standard deviations each direction. And then we're going to see how well it compares with the 68, 95, 99.7 rule when we actually look at our data of if most of the data falls in that area and so on and so forth. So got 15.6, and then I'm adding the 2.6, so 18.2, 20.8, and 23.4, and then subtracting it, 13, 10.4, and 7.8.
So is 15.6 the median?
Yeah.
Okay. Why is it different again from the median?
Or sorry, it's the mean.
Oh.
The mean, yeah. I wasn't registering what you said. And it's going to be slightly different because if you looked back at the histogram, while it's mostly uniform and symmetric or unimodal and symmetric, it obviously had the one that was out farther to the right, so it was a little bit skewed. So it's going to be just a little bit off, more than likely because of that. So that's why. All right, so now what we need to do is we need to see how many numbers are between 13 and 18.2 out of the total number that we have. So we're looking for how many are 1 standard deviation away. So many out of 44. And then 2 standard deviations is another number out of 44. 3 standard deviations. So what we're going to do, instead of you having to go back through the list and try to sit there and count through the boxes and see, your calculator has this lovely function that's called sort. So stat, and then it's called sort A. And in there we're going to put L1. So hit stat. Sort A means sort in ascending order. And then hit second stat to bring up the list and put in L1. And then it's going to come up and tell you that it's done. Okay. So then if you go back to stat, edit, your numbers are now in order, numerical order. Okay. So then we're looking for numbers between 13 and 18.2. So when I get to that, I'm going to start counting them. So I'm not going to count out loud, so y'all can count them and make sure we have the same amount. How many did y'all get?
31.
Okay. So 31 out of 44. So then in your list, we now need to see how many are between 10.4 and 18.2. No, 10.4 and 20.8. So you have 31, and then so basically we need to keep going up to 20.8, add that to the 31, and then also add in whatever 10.4 to 13 is. So it's going to be 31 plus... Y'all end up with 42 numbers. Okay. And then 3 standard deviations away. So 9.4 is in there. And then 22.8 is in it as well. So that means 44 out of 44 for that one. Always look, because sometimes a number might be outside of that if we had an outlier or something like that. This particular problem, I know we didn't find it, but there are no outliers in this problem. but if there are, it could be farther than those away. So now we need to calculate what these percentages are. So 31 out of 44 is 70.5%. 42 out of 44 is 95.5%. And 44 out of 44 is 100%. So comparatively to the 68, 95, 99.7 rule, they're basically the same. Okay. So it's very similar to the rule. All right, so now you need to go back for part D to second y equals, so go to your stat plot. We are now looking for this option that looks almost like a straight line of dots connected almost. Well, it kind of looks like they're connected. Data list is whatever you put your information in. Data axis is going to be X for this. Okay, we pretty much are always going to use X. And then zoom 9 again.
Wait, can you repeat that?
Yeah. Second stat plot.
Also, may I request you going back to your list because I accidentally messed up one of the numbers on the list when I was. Do we still need that list?
It's going in here, but that's it.
Yeah, but I accidentally put a ridiculous number in there by accident because I was multiplying.
Oh.
So I messed up my list. So.
Do you want me to read them off? Do you know what the ridiculous number is?
Yeah, it's after 12.4.
12.6?
12.6, okay.
Okay.
Well, I accidentally multiplied, I didn't exit out of the list when I was starting multiplying, so I got a okay, my list is now fixed.
Okay. So second y equals, so that's stat plot. It should be the last option that you can arrow to, assuming it's in the same order mine is. So it's this funky looking line with a bunch of dots. Data list is L1, data axis is X, zoom 9, and it should look like that.
Yep.
So, something like I know it's hard to see on here, but you have it on your, calculator. So this is a normal probability plot. Okay. So maybe it's not perfect, but it kind of looks like what?
Kind of like a line.
Looks skewed.
Linear.
Linear.
Kind of looks like a line. Okay, if you were to lay a pencil over top of it, you can pretty much completely cover it up. So the normal probability plot is approximately linear. So the normal model is okay. So our histogram was pretty unimodal and symmetric. Goodness. And our normal probability plot is mostly linear, so we were good with our normal model. well, that's about to answer question E. Getting ahead of myself. Having inspected the data from several different perspectives, do you think these data are approximately normal? Write a brief summary of your assessment that combines your findings in part A through D. So, yes, data is approximately normal. The normal probability plot is approximately linear. It followed, in general, the 68, 95, 99.7 rule. The histogram is unimodal and symmetric. Obviously, approximately on that as well. So, all conditions are met. So, it's okay to use normal model. And for 15.6, right? That's what it was. Yeah, in 2.6. Can you still not hear out of that ear?
Should I be concerned?
Maybe, slightly. I don't know. Does it hurt?
Sometimes.
Is it infected?
I hope not. I wouldn't, yeah. I don't want to see a doctor. Like, if I close this ear.
Can you hear me?
Okay.
I thought he was about to say, I cannot hear you. Be like, then.
What'd you say?
I was gonna be like, I think you can.
I couldn't. Yeah, I don't know why. I guess I don't know what it is, to be honest.
Can you, like, have you not been able to hear for, like, since yesterday? Or can you sometimes hear?
It's very muffled.
Oh.
I think it's just blocked, but I don't know how I have clean ear canals.
Maybe an infection.
What?
Maybe an infection.
I was there, are you congested?
Maybe it's allergies. I don't know.
It's just a weird place for your allergies.
I've been taking my allergies. I usually don't get my ears usually don't get blocked out. I don't know what it is.
Who knows? I'm sure you're fine. Hopefully it doesn't cause permanent hearing loss.
I hope you're not
Maybe
going
just
bad.
like catness, underneath condition. I'll start around for a bit. Came back eventually.
Alright, last one. Hens usually begin laying eggs when they are 6 months old. Young hens tend to lay smaller eggs, often weighing less than the desired weight of 54 grams. The average weight of eggs produced by the young hens is 50.9 grams, and only 28% of their eggs exceed the desired minimum weight. If a normal model is appropriate, what would the standard deviation of the egg weights be? Oh, never mind. Alright, so, whoa. Normal model. Mean of 50.9. Only 28% exceed the desired weight. So I need INV norm For Josh and I, 0.72, 0, and 1. Because I don't know the standard deviation, so we're assuming a normal model, which is already using 0 and 1. Nathan and Josh, you would use 0.28 and use right. Oh, nuts.
Happened.
Wait,
Oh.
where's I and V norm again?
Stat? No. Vars. Second vars. Number 3.
Got it. And wait, what are we plugging?
Y'all are plugging in 0.2801, right? Josh and I are plugging in 0.7201.
I feel like having to remember to press right is just a little.
You can always do it as left and just do it like we do it and just do 0.78, but then you have to do 1 minus, but that's what we have to do, so.
Wait, how'd you know what the area was?
Because it said 28% of the eggs exceed the desired minimum weight.
Okay.
So when we do that, what do we get?
What do we want it rounded to?
2 decimal places. Or if you're giving me the percent, give me the whole percent. But no, give me the decimal. Give me the decimal.
0.58.
0.58. All right, so now we need to find the standard deviation because we don't know what it is. So we're going to use the z. So this is our z value here. Okay, we just found z. So z equals y minus y bar over s. So then I can swap s and z. Okay, because I'm trying to solve for s, so I'm just going to go ahead and flip them. So the y value for this specific was 54 grams from the beginning of the problem, 54 grams. So 54 minus 50.9 divided by the z of 0.58. And that's going to give us our standard deviation in grams.
5.34.
So we've got a standard deviation of 5.34 grams. So then by the time the hens have reached the age of 1 year, the eggs they produce average 67.1 grams, and 98% of them are above the minimum weight. What is the standard deviation for the appropriate normal model for these older hens? So we've got another model. 98% of them are above. So that's all this in here. One day this is going to be fixed and it'll work. I don't know when it'll be, but. So 98%, okay, are above the weight. So we're going to do the same thing. We're going to do I and V norm of 0.02, because that's the left side. Okay, so if you're going to just do left U2, then you need to put in 0.02. If you're content with having to click right, then you can put in 0.98. So 0.02, 0, and 1.
Why are we using 0 and 1?
Because we don't know the standard deviation. So we can't use the mean if we don't know the standard deviation.
Okay.
So then the numbers in the parentheses, it goes area.
It's area, which is your percent, and then mean and standard deviation.
Okay.
Which if we know both of those things, we type them in, but we don't. And it says assume a normal model is okay. So that's why we're doing it.
I got negative 2.05.
Negative 2.05. So then we set it up the same way as we did the last one, so I'm not going to rewrite the formula. I'm just going to go ahead and write S is equal to, in this case, it's 54 minus 67.1, because that's the average, divided by negative 2.05.
I got positive 2.
Did you do right or left?
Right.
Did you do 0.98 or 0.02?
I'm sorry.
Did you do 0.98 or 0.02?
0.02.
That's why.
Okay.
If you're going to do 0.02, you need to do left.
Left. Okay. But if I do.
But if you do 0.98 and you do right, it will give you the negative. Or it should. Right, Josh, you said negative, right?
Yeah.
Okay.
Okay. Yes.
Okay.
6.39. Right.
So 6.39 grams is my standard deviation. Whoa. There's dirt. Is my standard deviation for that one. So are egg sizes more consistent for the younger hens or the older ones?
The younger ones,
Why?
the standard deviation is smaller.
Yep. Younger hens are more consistent. Because standard deviation is smaller. We are not going to do the last problem. It ends up being more confusing than anything for people typically, so I'm going to leave it off. Your homework problems, because I don't have them typed up, are all right. Are y'all ready to write them?
Yeah.
I'm just writing them at the bottom.
Okay.
All right. 5, 7, 11, 19, 21, 25, 27, 37, and 39. I know that kind of seems like a lot. But I will say some of those, like there are 2 or 3 of those problems that are a continuation of the cow problem from the first day. So just be aware of that. Tomorrow you'll have time to like work on this and also to study for the quiz on Friday. I don't think the quiz should be too bad. And I think y'all already took a picture of the questions. The like questions that go with it, yeah. But I'll print off
May
the.
not remember.
Actually, I think I already gave you the printout of those from when I gave you 1 through 4. I think I gave you 5 and 6 as well. Okay. I was gonna say if not, I need to give you those.